Could UFO sightings be clues to life out there? This year, the James Webb Space Telescope has stunned the world with K2-18b, a planet 124 light-years away, boasting a 99.7% chance of life that might outshine Earth. Picture a water world alive with possibility. Welcome to Before the Light, your journey into cosmic mysteries. Join us as we explore this incredible discovery. The year was 2015, and humanity's gaze turned skyward with renewed hope. The Kepler Space Telescope, a veteran of cosmic exploration, embarked on its K2 mission. A second act after its primary mission faced technical challenges. This time, its watchful eyes scanned deeper into the galaxy, capturing the faint light of distant stars. Among the countless data points, a signal emerged that would captivate scientists for years to come. Over 1,200 exoplanets flickered into view, each a potential world waiting to be understood. Yet one stood out with a mysterious allure: K2-18b. This planet, nestled 124 light-years away in the constellation Leo, revealed itself as a giant compared to Earth. Measurements showed it spanned 2.5 times our planet's diameter, while its mass tipped the scales at nearly 9 times Earth's weight. Such numbers hinted at something extraordinary: a world large enough to hold secrets, yet not so massive as to rule out habitability. Kepler's initial observations, conducted with precision, marked the first step in a journey that would challenge our understanding of life in the universe. What made K2-18b intriguing from the start? Its orbit around a cool red dwarf star placed it in a zone where liquid water might exist, a key ingredient for life as we know it. The telescope's data, gathered through the transit method, detected the planet as it passed in front of its star, causing a small, barely noticeable dimming of the star's light. This dip offered clues about its size and position, sparking curiosity among astronomers. Could this be a world where life had taken root? The question lingered, unanswered but tantalizing, as Kepler's findings set the stage for deeper investigation. Scientists marveled at the implications. A planet of this size with such a mass suggested a structure unlike our rocky home. Some wondered if it might harbor a thick atmosphere or even an ocean beneath its surface. The K2 mission's discovery wasn't definitive proof, but it opened a door. Teams across the globe pored over the data, eager to learn more. K2-18b became a name whispered with excitement, a guiding sign in space, hinting that we might not be alone. From that moment in 2015, the hunt for life beyond Earth gained a new target, one that would soon draw the attention of the most powerful telescope ever built. By 2017, the quest to unravel K2-18b's mysteries gained momentum. Scientists turned to the Spitzer Space Telescope, an infrared observer orbiting above Earth's atmosphere, to refine what Kepler had begun. Its sensitive instruments peered through the cosmos, confirming that K2-18b resided within the habitable zone of its red dwarf star. This sweet spot, where temperatures might allow liquid water to flow, ignited imaginations. The planet's orbit, just 2.5 times closer to its star than Mercury is to our Sun, received just the right amount of dim, cool light from its star, hinting at conditions where life could take hold. Spitzer's data painted a picture of possibility, sharpening the focus on this distant world. Meanwhile, halfway across the globe, a different tool joined the effort: the High-Accuracy Radial Velocity Planet Searcher, or HARPS, operated from a Chilean observatory. Its spectrograph analyzed the starlight in detail. This instrument measured K2-18b's density by analyzing the subtle wobbles of its star, caused by the planet's gravitational pull. The results suggested something astonishing. Beneath its atmosphere might lie a vast ocean. Water, the essence of life on Earth, could be pooling on this alien surface, hidden from direct view. Astronomers exchanged excited glances as the data hinted at a world unlike any in our solar system. These twin discoveries in 2017 elevated K218b's status. Spitzer's infrared gaze and HARPS's meticulous measurements built a foundation of hope. The habitable zone offered a stage, and the idea of an ocean raised hopes that life could exist there. Yet questions lingered. Was this merely a gas giant with a watery veneer, or something more? The scientific community buzzed with anticipation, knowing the next steps would demand even greater technology. K218b had become a puzzle, its pieces slowly coming together under the watchful eyes of Earth's telescopes. The year 2019 brought a pivotal moment in the saga of K218b. High above Earth, the Hubble Space Telescope trained its lenses on this distant world, its veteran instruments probing the faint glow of a planet 124 light-years away. What emerged from the data was a revelation that shifted perspectives. Water vapor was found in the atmosphere of K218b. This discovery, captured as the planet transited its star, marked a turning point. The presence of H2O, a molecule inseparable from life on our planet, suggested that the ocean hinted at by earlier observations might indeed exist. Scientists leaned closer to their screens, hearts racing with the implications. Hubble's ability to dissect starlight revealed more than just water. The telescope's spectrograph detected specific wavelengths absorbed by water vapor, a pattern that was clearly different from background signals. This wasn't a fleeting trace, but a consistent signal, hinting at a substantial atmospheric component. For the first time, the idea of a deep, life-supporting ocean beneath K218b's thick hydrogen atmosphere felt less like science fiction and more like a tangible prospect. The red dwarf star's dim light filtered through this watery veil offered a glimpse into a world that might harbor the conditions for biology. Astronomers around the world were excited by the discovery. Water vapor transformed K218b from a curious anomaly into a prime candidate for habitability. Yet caution tempered the enthusiasm. Could this moisture sustain life, or was it just an illusion in a vast, gas-filled world? The discovery fueled debates, with some envisioning microbial ecosystems thriving in alien depths, while others urged patience for further evidence. Hubble had lit a beacon, but the full story remained unwritten. This breakthrough in 2019 set the stage for the next chapter, drawing the gaze of an even mightier telescope toward the stars. The year 2025 has ushered in a defining chapter for K218b, and the James Webb Space Telescope stands at the forefront of this cosmic breakthrough. Equipped with advanced instruments, James Webb Space Telescope's mid-infrared camera turned its gaze toward the 124 light-year distant planet, seeking answers where Hubble left off. What it found surprised and amazed scientists worldwide: traces of dimethyl sulfide DMS, a compound rarely produced outside living organisms on Earth. This discovery, confirmed with a 99.7% confidence level, marks the strongest hint yet of life beyond our world. Researchers held their breath as the data unfolded. DMS, a gas linked to phytoplankton and marine microbes on our planet, appeared in K218b's atmosphere at a concentration 1,000 times higher than Earth's levels. On Earth, this gas is what gives the ocean its salty smell. That's the scent of DMS released as algae decay. Here, its presence suggests something extraordinary might be happening. James Webb Space Telescope's precise observations, gathered as K218b, transited its star, detected this molecule's unique infrared signature, a weak but clear signal. The telescope's ability to analyze light filtered through the planet's atmosphere revealed a chemical fingerprint that stirred awe and debate alike. Yet certainty remains elusive. The 99.7% chance which scientists call a 3 sigma level of confidence, still below the 5 sigma level scientists usually require before calling something a discovery, a bar set by discoveries like the Higgs boson. This means the result is very likely real, but not yet certain enough to be called proof. Could this be a glitch, a misread signal, or an unknown geological process? To rule out errors, NASA scheduled repeated scans with different instruments. This year's findings, while groundbreaking, demand further validation. Still, the image of a thriving ecosystem, perhaps an ocean pulsing with life, captures the imagination. James Webb Space Telescope has lit a spark, urging humanity to look closer at the stars. K218b's story takes an intriguing turn as scientists ponder its true nature. This planet, orbiting a cool red dwarf 124 light-years away, may belong to a type of planet called a Hycean world, with oceans beneath thick, hydrogen-rich skies, planets blanketed by deep oceans beneath hydrogen-rich atmospheres. The absence of ammonia in its air, a gas that would dissolve into water if present, strengthens this hypothesis. Instead, the atmosphere's composition hints at a watery expanse, potentially stretching across the planet's surface. Yet, the journey to confirm this vision is fraught with challenges and conflicting views. What fuels this possibility? K218b's orbit, just 2.5 times closer to its star than Mercury is to the Sun, delivers a balanced dose of heat and light thanks to the star's dimmer output. This delicate equilibrium could sustain liquid water even under a thick hydrogen blanket that acts like a cosmic insulator. Temperatures might hover around a life-friendly range, though estimates vary. Some models suggest a stable 120 degrees Fahrenheit, ideal for biological processes, while others warn of extremely hot conditions where life may not survive, where life as we know it couldn't survive. The pressure at depth, potentially reaching 2,400 atmospheres, which is thousands of times more pressure than on Earth's surface, adds another layer of complexity. Debate rages among experts. Dr. Nicholas Vaughn from NASA's Research Center argues K218b might be a miniature gas giant, lacking a solid surface and thus unfit for life. He points to its mass, 9 times Earth's, as evidence of a gaseous nature. Conversely, Professor Niku Madhusudan from Cambridge's Institute of Astronomy champions the ocean world theory, citing the DMS detection as a sign of biological activity. His team believes life could thrive in these alien seas, perhaps in forms unimaginable to us. For now, the truth hangs in balance, awaiting further data. K218b remains an enigma, its potential both thrilling and uncertain. The tantalizing hints from K218b ignite a spark of wonder. Could life flourish on this distant world? With a 99.7% chance of dimethyl sulfide DMS signaling biology, scientists dare to dream of what might thrive beneath its hydrogen-rich skies. The planet's potential Hycean nature, deep oceans under immense pressure, might support forms of life very different from anything we know on Earth. Yet this vision remains a hypothesis, an idea based on speculation, not confirmed evidence. Let's peer into the possibilities that stir the mind. Picture a realm where microscopic life forms dominate. Tiny organisms, perhaps akin to Earth's extremophiles, could harness hydrogen and methane to survive. These microbes might glow with bioluminescence, a natural light some deep-sea creatures on Earth also produce, casting an eerie light through the murky depths, their energy drawn from chemical reactions rather than sunlight. Deeper still, larger creatures might evolve. Imagine jellyfish-like beings, their translucent bodies drifting gracefully, adapted to pressures reaching 2,400 atmospheres, equivalent to thousands of times the pressure we feel at sea level. Their structures, built to withstand such force, could pulse with a rhythm alien to our oceans. Even grander speculations emerge. Some envision massive organisms, giants of the deep. They're shaped by extreme gravity and pressure that could influence how life develops in unfamiliar ways. These creatures might rely on the planet's thermal vents or chemical gradients, heat sources like underwater vents or changes in chemical levels, similar to Earth's deep ocean for sustenance, thriving in an environment hostile to human life. However, caution tempers these dreams. The absence of direct evidence means these life forms remain theoretical. Geological processes could mimic DMS production, or the conditions might prove too harsh. Until probes or advanced telescopes confirm otherwise, K218b's biosphere stays a story we tell ourselves, a thrilling, unproven tale of life among the stars. K218b may hint at life's presence, but it's not the only world sparking curiosity across the cosmos. The universe teems with candidates that could harbor life, each offering a new chapter in our search. As we stand on the edge of this cosmic revelation, K218b beckons from 124 light-years away, a world that might rewrite our story. The James Webb Space Telescope's detection of dimethyl sulfide, with its 99.7% chance of signaling life, challenges the mystery of whether we are truly alone in the universe. This Hycean planet, with its potential oceans and alien ecosystems, stirs a profound question. Are we truly alone? The journey from Kepler's 2015 glimpse to this year's breakthrough has unveiled a universe teeming with possibilities. Yet the path ahead remains uncharted. The 99.7% probability, while thrilling, falls short of the 5 sigma proof demanded by science, a reminder that caution guides our excitement. Future missions, armed with advanced tools, will seek the definitive evidence we crave. Until then, K218b stands as a symbol of hope, a symbol of our hope to find life beyond Earth. What does this mean for us? Perhaps K218b marks the end of our cosmic isolation, a stepping stone to a galactic community. Imagine one day meeting life from other planets, their forms shaped by worlds like this. Before the light invites you to ponder this vast unknown, subscribe to join our next adventure. Will the stars answer our call? Until then, gaze upward, for the universe holds secrets yet to unfold.